Okay, so let me start. Hello.
Hello.
I'm Choroba. I'm from Prague, and I work for Good Data, which is a Czech and a bit American and Vietnamese company that uses Perl. I am present. I visit PerlMonks, CPAN with some of my modules, Stack Overflow, and many more. So you might find me anywhere there. This is my email. Okay, so what I'll talk about is threats, threat unsafe modules, and an alternative. So I'll start with a story because, as Ovid said, programmers love anecdotes. So it all started with a GUI client for the PerlMonks chatterbox. So for those that don't know what it is, so PerlMonks have some kind of a chatterbox, which in fact is just a form in the web page that shows what anyone sends there. And it's kind of inconvenient. And there are several like alternative clients, but they still have some drawbacks, like the history is very short or whatever else. And what many people used for years, or had used for years, was a bridge to IRC from this chatterbox. So you just connected to a channel on IRC that showed all the messages going to the chatterbox, and if you sent a message to this channel, it was displayed in chatterbox as well. So this worked nicely, but it had occasional hiccups, and if the author was not available to like restart the server, it could take several days to come back on. But the main problem was, you can probably not see the last word, it stopped working after PerlMonks switched to HTTPS. And the original author didn't have enough time or interest to fix it. So I decided I would write a new client. Okay, so I started with a selection of modules to use. So I used www Mechanize to communicate with PerlMonks. I used XML, libXML to process the messages from PerlMonks because what they send is XML or very close to XML sometimes. And TK for the GUI. And fetching something over the internet, sometimes it takes time or even gets stuck. And I didn't want the GUI to get stuck. So I used threads and thread queue to make the GUI responsive even when the communication is somehow stuck or waiting for something to happen. And there were many more modules, the usual stuff like list util and whatever else. That's probably not worth mentioning. So this is how the client looks like. If there are new messages, you are notified in the title, which is also displayed in the, how is it called? Panel or panel, I don't know, yeah. You can save the log and load it next time to have context. You can configure it in various ways. Here it shows how you can list active users. So basically what a common chatting clients provide. And so on. Okay. You can find the source code in GitHub. patches welcome. So something about how it works. So there are three main components. I call them GUI, communication and control. The main program runs the GUI and starts another thread that runs the control and starts another thread that runs the communication. And they communicate between themselves via three queues, which are here in green. It seems quite complicated, but in fact, the control is very easy. It just handles the startup and clean exit in the end. It doesn't do anything else at the moment. Okay. So how many of you are familiar with threads? Most of you, or at least half. Great. So threads in Perl, you just create a thread by giving it a subroutine reference, and it runs the code in a thread. So if you run this code, the projector, thank you, you get something like this back, and the order of the first two lines can be different. You never know which will come first, because it happens in a different thread. Okay. In threads, when you create a thread, it creates a copy of everything that has been done so far, all the variables, the whole environment. But anything created afterwards stays within the thread and is not shared. And the environment is not shared either because it's copied. So if you want to share something between the threads, you need to use threads shared. So again, here is a short example. We have to say that we will use shared threads or threads shared. Via an attribute, we can say that a variable is in effect shared between the threads. And then there is one thread that increments the variable many times, and just time to time we inspect the value. And the output can be something like this. And again, the numbers might be different on each run, or should be, in fact. Okay. But this is very low level, and when working with threads, I prefer to use threadq, which is a nice library that hides much of the low-level stuff. And what you do, you create the queues, which are basically the shared FIFOs between the threads. And you can, by using inqueue, you can insert something into the queue, and by using dequeue, you fetch the first value from the queue from another thread. So here again an example. Okay. Sorry. Yeah. This is enough. Okay. So we don't have to specify threads shared anymore. It's handled in thread queue. So we create a queue. Then we create 3 threads. Each of them dequeues a value and prints 2 to the power of that value. Again, we pretend that it's like a long time computation by adding sleep 1 into the thread. And then we'll just put numbers 1 to 10 into the queue. Then we'll say end, which means this tells the threads that the queue will not receive any more values. And we'll use join to wait for the threads to finish. They should, the subroutine here returns thread ID done, which should be what this join returns. And again, this is what we can get back. You can see that the thread number 2 returned 2, thread number 3 returned 4, and so on. And at the end, we got done, done, done from all the 3 threads. Again, the numbers of threads might be displayed in different order. Even the numbers might be displayed in different order. Somehow, when you pipe the output, it behaves completely different to what you get in terminal. Okay. So, thread safety. There are modules, basically, this concerns mainly access modules that are not thread safe, which means there is some kind of a state saved somewhere in the C code of the module, and it doesn't behave nicely with the threads, which means there is some kind of a global state that gets modified from all the threads. But sometimes one thread saves something and wants to retrieve it back, and if you override it from another thread in the meantime, it can crash your program. It can get you can get wrong results, and it's very hard to debug. So you must be very careful when using threads and any external modules that don't say that they are thread safe. There are some ways how to overcome it. I'll show it here. So we'll start with an example. One of the modules that I used was TK, which is not thread safe. So, short example, we'll create a thread, and in the thread we'll create a main window, which is like just the basic application window. When I ran this to generate the output, I just killed the window by hand. There's like no, yeah, it doesn't work without user interaction. So when I ran this, I got an error, or better, a long list of errors. Okay, some of them are really interesting, and in the end we have segmentation fault. So this is really something you don't want to happen to your program. Fortunately, there is a simple solution how to prevent that. So if you want to combine a thread unsafe library with threads, use the problematic module only in a single thread. And to prevent loading it into some other threads, only require it in the single thread after all other threads from this thread already been spawned, and use require instead of use to prevent it loading at compile time. So it really gets compiled later, and there are no new threads created afterwards. Which is not that problematic, because for this example, we just can, this use TK will be moved here and changed to require TK. This still doesn't work because we didn't import TK, so this main loop is now like unknown. So you can prefix TK because import is not needed. There's nothing really important happening in case of TK. And this works. No seg fault, and works nicely. And that's basically how the client works. Okay, so Perl documentation is aware of these problems. So if you read the Perl thread tutorial, it basically starts with this Perl threads are not X threads for all values of X. They are POSIX threads, or DEC threads, or Java's green threads, or Windows threads. Which, to me, was like, okay, they aren't X, but what are they? Basically, I came to Perl from BASIC, Pascal, and Prolog. I had no idea of threads. So, and I don't care what threads there are in Java or wherever else. So I was kind of confused when I read that for the first time. And the documentation of the threads library itself didn't help much, because it contains this warning: the interpreter-based threads provided by Perl are not the fast, lightweight system for multitasking that one might expect or hope for. Again, I want to know what it is, not what someone else expects it to be, which it is not. Threads are implemented in a way that make them easy to misuse. Okay, few people know how to use them correctly or will be able to provide help. Okay, the use of interpreter-based threads in Perl is officially discouraged. This is like a strong word, and I looked it up in Perl glossary. It's not there, it's in Perl policy. And it says that discouraged means that from time to time we may mark language constructs and features which we consider to have been mistakes as discouraged. Discouraged features aren't currently candidates for removal, but we may later deprecate them if they are found to stand in the way of a significant improvement to the Perl core. There is a long-standing bug that tries to reformulate these things, because I guess no one really wants or plans to remove threads from Perl core. But every time this thread gets revived, it ends up in a like heated discussion, and there is no solution, unfortunately. So on PerlMonks there is one person. His name is Mario Roy, and he created a module called MCE, which stands for Many Core Engine, and it's one of the few modules in CPAN that have pictures in the documentation. Wow. Okay, but he proposed to me to use some of the submodules of this framework to implement the client. And there are two different implementations. One of them uses MC Shared and MC Hobo, one of them MC Channel and MC Child. The second one is a bit lighter, because the MC Shared and MC Hobo need like one more process to handle the management of the processes, while these two, they just run independently and they don't need anything to synchronize them. Okay. So, sorry. And what was interesting, that when porting the application to MCE, the changes were pretty simple. So this was the original code. It used thread queue to create the three communication queues, and then it created a thread somewhere. So when porting it to MCE, I just had to use the class names. You can see. Everything else stays the same. Unfortunately, for the other pair of libraries, the name of the constructor was different. So what I did, I just stored the class name and the constructor name in a hash. I populated the variables and then did this. So the code works with anything you like from the three possibilities. And so how does MCE work? On Microsoft Windows, it uses threads because they use native Windows threads. And it uses threads also if it finds that it's running in scope of use threads. Otherwise, it uses fork and uses sockets to communicate. So, conclusion. Threads are confusingly documented. Threads are dangerous. You should use thread queue to avoid the low level. You should, if you want to use thread unsafe modules, you should use them in a single thread and require them only. And if you are scared of threads, you can try MCE. Thank you. Any questions? Yes? Well, nice question. Yeah, I'll repeat it. So what's the difference in performance between threads and forks? I don't know. It probably depends on how many data you need to shift between the processes or threads. And in case of a GUI application where I don't use threads really for like speeding it up, I don't care. I just need like two processes to cooperate. So you have to benchmark. There probably are some differences, but they might be like operation system dependent or something. Yeah, I think that threads should be faster, but who knows? Who knows? I haven't tried it. Yes?
Why you prefer threads instead of forks initially?
Initially, well, for one, I wanted to try, because I read somewhere that it's possible to run thread unsafe modules with threads using some techniques, so I wanted to try that. And in fact, I think that using sockets is like much more complex than using threads queue or thread queue. It's really easy. So that's why I chose those libraries initially. Yeah. Yes?
Why are you not using any event or something?
Okay. I know that it's possible. I repeat the question. Why I didn't use any event or some other similar library, POE or whatever. Yeah. Basically, TK already has an event loop. And combining event loops is something I didn't want to go into. It's possible, like many libraries already have, like TK is something that's well known, so there probably are like prepared ways how to do that, but I didn't want to go into it. Yeah. And it should be possible as well, yeah. But in that case, you have to like change everything. You can't use, I used just LWP simple to, or no, triple W mechanized, okay. But nevertheless, you will have to like use something different there to cooperate with the event loop. This makes it quite possible, quite simple to just add threads and not change the code at all. Yeah. You had a question.
I don't know if it's an intelligent question.
Let me judge.
Since I use decay and the event loop, I know that there's this alarm feature in Perl. If you want to wait for something, but you don't want to block.
Alarm.
Yeah.
Yes. And?
Would it be possible to use alarm to communicate with decay without blocking?
I am not sure, and I wouldn't recommend it because TK has its like own event loop and timers and stuff, and I'm not sure these two will play nice together. So
I'm not sure if this was an intelligent question.
Yeah.